folks, welcome back to the shop. Frank here. Got an interesting project I'm starting on today. I got a sheet of 3/8" steel loaded onto the plasma table, and I'm going to cut some parts out of it. This is going to be for, again, a commission from the local gun club. It is a target array of a particular type, though nothing quite like this. I've never seen anything quite like this. So I'm not going to tell you what it is exactly. Let you figure it out as we go along. If you think you know what it is, put in a comment. This may take a couple episodes to get done. There's a lot of fabrication here. So we'll get started, fire up the plasma table, and go from there.
So I'm setting a piece of 3/8" plate steel down on the plasma table using the magnetic lifter. This piece of plate steel weighs about 125 pounds, something like that. So it's a little easier to handle with the little jib crane. If you haven't seen my plasma table before, I've got a tank down here which the table drains into, so I pump the water from that tank back up into the table. It's just a regular sprayer tank that you might find at Harbor Freight or Northern Tool. I think Northern Tool. Got a 12-volt battery which runs the sprayer pump, and a desiccant dryer here with the yellow label, and a refrigerated air dryer, which I turn on now. I'm going to change the torch, nozzle, and electrode. I do this periodically. It's good for about 30 minutes of continuous cut time, which for thicker plate steel, obviously you're cutting that at a slower speed. So in terms of amount of cutting, linear feet of cutting, it's much less for a thicker steel. Here's the worn nozzle. It's eroded, and the end of the electrode is eroded too. Not as badly as the nozzle. Here's a new nozzle. We'll start with this one. Drop it back in, put in the swirl collar, and screw it back into the torch. This is a machine torch. Some people use handheld torches and clamp Z-act. This is a machine torch. I've got to add some makeup water. The table is a 5% solution of plasma green 1050, which is an anti-corrosion additive that gives it color. And over time, water, of course, evaporates, leaves the additive there, so you just really need to add clean water, makeup. I like to keep the level about a 1/4 inch below the lip of the table, 1/4 to 1/2 inch. Looks like it might be a little bit lower here, but it could be okay. Obviously, the purpose of the water is to keep the torch from burning through the pan. So I'm running the torch back and forth just to make sure it runs parallel to the edge of the plate. I have a little Bluetooth keyboard that I use to maneuver around. So I'm going to bring the torch down to the lower left-hand corner. That's going to be my 0. That'll be my XY 0. Go ahead and start the torch. First thing it does, it cuts the holes, and then it will cut the outside of the plate part. You can set the program to cut the outside first, then the inside loops. Generally, you cut the inside loops first so that the material doesn't move. If you cut the outside first, then your workpiece might move a little bit, and your inside holes then, for example, might be out of place a little bit. Let's cut the 4 holes now. It's pierced through and is going to cut the perimeter This is 3/8 inch A36 plate steel or mild steel, structural steel, and it normally cuts at 27 inches per minute. Of course, this is sped up like 10 times here. This is much faster than that. All right, so this is going to finish up, and I slowed it down to normal speed here for the last couple seconds. All right, so since the torch cuts through, it does leave a little slag on the underside sometimes, and occasionally where it pierces, you get a little piece of metal stuck together. So breaking it loose, the slag is very brittle, so a tap with a hammer normally jars it loose. So the parts usually come right off just like that. One of the little holes didn't fall through. A little piece of slag just holding up the plug, knocked the plug out. There it goes. Got a little bit of dross or slag on the back edges, back surface of the cut's pretty typical. So just knock that off with this stiff putty knife, and just comes right off. You push it toward the edge, and just basically just knocks right off. All right, I got to start cutting some more parts here. I'm using my Grizzly mitering bandsaw, and we've got some angle iron here. I think this is 2x2 by quarter. I've got a couple parts this to cut, and this saw is pretty good. The key to using an inexpensive saw, and this saw is pretty similar to a lot of saws in the price range, except that it miters, which is nice. But key is good blades, and these are Lennox blades. I think it's from discountbandsawblades.com. We've got a couple cuts here to make. I need 2 pieces 80 inches long. So that's what I'm working on here. All right, got my 2 main rails. Cutting some more pieces here, legs and cross braces.
I've got my end brackets, my main rails here set up on the table, squared up. Gonna tack them together, then turn it around, put the other end plate on. Yeah, the most important thing here is that the two rails are parallel. What you doing, Butchie boy? What you doing? Yeah. What you doing? My good puppy. My good puppy. I'm not a puppy anymore. What's Brutus up to over here? There's the Brutus. There's the Brutus. There's the Brutus. Okay. I will show you one thing, maybe. The camellias are along the fence here, are in full bloom. And then back here behind the workshop, got white, pink. There's a red one over there someplace. So for those of you up north, you're probably not familiar with this plant. Depends on where you are on the coast. If you're on the coast, if you're coastal, then maybe see these further north. But they're camellias, and called the rose of winter. They bloom in the winter or fall. Some of them bloom in the spring as well. So I think over here, the first plant is Rose of Sharon, losing most of its leaves. There are 4 pink camellias. Then there's 2 spring blooming camellias on the end there that are not in bloom now, and more Rose of Sharons further down that have lost all their leaves. So those 2 non-blooming shrubs there are also camellias, but they're spring blooming. I'll tell you, standing back, it doesn't look level, but it's pretty darn close. Pretty close. I'm basically just tacking that right now. So this is 80 inches long, and I'm just marking every 20 inches. I'm going to put 1 brace in the middle, and then 1 here and here, and we'll run diagonals to the legs. 66 degrees. So one of the nice things about this saw is that the head, you can angle the head. Got a scale here. So I measured 66 degrees from vertical, so I'm going to cut these at 24 degrees. That'll give me complementary angle. That's actually really close right there. That's right on it, money. All right, folks, I need to make a couple of tabs. Actually, I need to make 4 of them to attach the diagonal braces to the horizontal brace on the leg and the braces underneath the main rails on the top of this rack. So I'm in Fusion 360. This is the free version for personal use. You have to have internet connectivity to use this product. Most of the work products are stored in the cloud or online. Anyway, so I'm going to create a sketch, and I need to pick the plane that I want to do it on. I always pick the front plane up here on the right. I pick the front XY axis basically, and I'm going to make a little tab, which is just a little flat rectangular piece with a hole in it that will weld into the angle bracket, the angle iron, in order to create a hole to bolt a diagonal brace to. So I think I'm just going to make about 1.5 inch square bracket, and when you draw a rectangle in here, Fusion, you pick the rectangle tool, you get the data fields and you can tab between them so you can actually create something with the desired dimensions. So I just created this rectangle. I don't want any sharp corners on here. I'm going to take this bottom left corner, the origin, and since it's going to fit inside the angle iron, I want to create a little rounded corner, pretty small one, which is so that it fits into the angle iron without having a sharp corner hitting the fillet inside the angle iron. My angle iron is 1 inch by 1 inch, so this is 1.5 inches by 1.5 inches. And we'll go up to the sheet metal area, pick the filleting tool, and we'll round over. I don't want that big a radius, maybe 0.25, something like that. and do the same thing in this corner. Pick the two sides. You pick the radius that you want, type it in. Again, don't want any sharp corners, that's fine like that, don't really matter. Alright, so this bottom left corner will go into the angle iron, which will go 1 inch on this side, 1 inch on this side. And I need a hole. I'm going to bolt. So I'm going to pick the circle tool, draw a circle. The diameter of the circle, I'm going to, because the plasma torch doesn't cut a perfectly straight-sided circle, the sides tend to be a little tapered. I need, for a 1/2 inch bolt, I need a slightly larger diameter. So I'm going to do 0.62 inches. So that'll be my hole through this tab. So that's it. That's really the tab. So we just need to, if you rotate it, you can see it's just in a plane, right? It's a sketch. So we need to turn it into a body, give it some thickness. So we can right click on it, click press pull, which really is just extrude. And we're going to extrude it backwards, 0.25, 1/4 of an inch. Hit enter, and there we've got our tab extruded with a 0.62 diameter hole. So that'll give us enough clearance for a 1/2 inch bolt without having to worry about reaming it out. When the plasma torch cuts something, you know, there's water splashes up on the surfaces after it's cut, so you get, you know, quenching, which hardens the material. So the edges of a plasma torch cut part are very hard. So if you make this hole undersized and try to drill it out, you'll ruin your drill bit. The only way to do it is with a carbide burr or something like that. So if you need an exact size hole for a machine fit, then you need to drill it after you've cut the part out, or you need to go through an annealing process to remove the brittle, very hard material around the edges of the cut part. So up here in the left hand corner, I go from design into manufacture. First thing you need to do is create a setup, basically tell it what we're going to do with this item. We're going to, by default here, I've got a cutting tool loaded, which could be plasma, could be water jet, right? So that's fine. Go on to the stock tab here. We don't want to add any additional stock. And in the post-process tab, I'm going to give it a name. Brace tab. Alright, then we need to go to the cutting module here and create a profile. Select a tool from the library. This is my Crossfire Pro torch. Each torch has, you know, different parameters that you load ahead of time. This particular profile defaults to 40 inches per minute cut speed, which is fine for 1/4 inch material. If 3/8 you'd cut at 27, or I cut at 27. 1/8 inch I cut at 65. So we're going to cut this out a 1/4 inch, so that's appropriate. And we just need to select the contour that we're going to create a cut path for. Click OK. It generates a cut path. So it's showing entering here at the red dot, going around a circle, coming out, moving over here, entering here on the side, going around the rectangle, and then coming out here. So this is the cut path. And we can run a simulation. Sometimes it's a good idea to do that, just to make sure you're cut everything you want. And this big round circle that's moving around is actually the torch, which is 1 inch in diameter. So you get this, and when it's firing, it's yellow or orange. Alright, so that's exactly what I want. So we can exit the simulation, post the G code called Brace tab,
Pierce delay 1.5, which is appropriate for a 1/4 inch. So we can post it, overwrite the existing file. Okay, so there it's successfully posted. All right, now we can go to Fire Control and open that file, and there we go. There's the file. So Fire Control is the software which drives the plasma table. Down here on the bottom, you can scroll through the G code to see what the instructions are. We'll set a program origin down the bottom left corner. Actually, we're going to cut 4 of them. So we'll do 2 rows and 2 columns. So we'll cut 4 like that. Again, we'll select this, get the table set up, get the torch to its proper location, and zero it out and cut these parts.
All right, I've got the torch set up. I need a space about 4 inches square to cut the 4 tabs. And I've got room here, obviously trying to conserve as much material as possible. All right, I'm going to go ahead and start it. It's normal to have a little bit of slag on this edges, chips right off. So I want it to be in the center of the main rail, which means I can't just find the center of this cross piece. I need to determine it this way. That's pretty close. Okay. Where have you guys been? Huh? My Brutus and my Butchie. Yeah, you being good boys. Come here. Let's huddle up. Huddle up. Huddle up. Come here. Huddle up. Sit. Huddle up. There we go. This is our huddle maneuver. All right. Good boys. They don't like the air compressor, plasma torch, welding, any of that stuff. They run out as soon as I turn anything on. But everything's off now, so back in here. Such good boys. They got new GPS collars on now. These are the Phi collars. We'll see how the battery life is. The Phi Series 2 that I've had, batteries didn't last very long. Got to the point where they were 98%. Well, that's pretty good. I just put them on one day. They're down 2%. That's way better than 96%, 4%. Way better than the old collars. The Series 2 collars got to the point where I had to recharge them every 3 or 4 days. And even at the best, they were only lasting, maybe 10 days when they were new. So they're GPS collars, and they have a cellular connection. You have a subscription to a cellular connection in case they get lost. And they did get lost one time. Actually, they were about a mile down the road. So somehow they pushed one of the gates open, and my phone says they've left the property. So come up, get in the van with the crates and go down the road looking for them. We found them pretty quickly, so that was pretty good. But these guys, pretty cagey. So got to have the GPS collars on them. There was one time where they were gone for several hours, and before we had the GPS collars, and they were quite a ways away. Anyway, so they got the new Phi Series 3 collars on. I like the technology. The battery life remains to be seen. The Series 2 collars I had, the battery life was not very good. So we'll see how these work. Anyway. All right, folks, I'm going to wrap up the video at this point. By now, some of you for sure have an idea of what this is going to be. So if you think you know what it is, put your guess in the comments. But I'm going to add a twist, because while you may have an idea, you don't know exactly. You have to factor these into the picture. And if not these particular ones, very similar to these in some fashion, will be incorporated into this project. So what you have in your mind does not include these. So you can take a guess to see what you think it might be. Anyway, that's it for this week. Leave a comment if you think you know what's going on. We'll come back next week and work on it some more. So thanks for watching. We'll see you then.